Okay, students, so let's do some refresher on the transformations, right? So if A is negative, we can call it a vertical reflection. Or sometimes we call it reflect over the x-axis. They are exactly the same. Okay, now if the absolute value of A is less than 1, then we call it a vertical. Yes, the word vertical is very important. Vertical compression. Okay, factor of whatever that value is. Okay, so let's say i.e. we have a, let's see, 3 over 4 is your A. So i.e. A equals 3 over 4. Well, absolute value, guys, of 3 over 4, okay, it's positive 3 over 4, which is still less than 1, so it's a vertical compression. Now, if the absolute value of A is bigger than 1, then we call it a vertical stretch. Vertical stretch. Factor of, or just of, factor of whatever A is, okay? So we're gonna say, i.e., what if A is 1.5 or 2 or 3? Well, absolute value of A, okay, absolute value of 1.5 is still positive 1.5, so that's bigger than 1. So it's going to be a vertical stretch factor of 1.5. Now, we want to talk about another one. A equal, let's say, negative 5. Absolute value of A, students, okay, in this case, absolute value of negative 5 is 5. So this is still a vertical stretch factor of 5. Now, the negative here will have two transformations, a reflection over the x-axis and a vertical stretch factor of 5. Your H and the K, that's going to be up or down and left and right, okay? So H, positive H, this is going to be right H units. Negative H is going to be left H units, whatever the units are, okay? We have positive K, that will be up K units. And negative K is going to be down K units, whatever numbers those will give us. Okay, so these guidelines to graph, it's the same as what we've seen before. Number 1, identify the parent functions. We have studied many already. In this particular case, the parent function is going to be y equals 1 over x. Make a table of values for the parent functions. In our particular case, we have 6 points. Okay, so make sure we know. We need to identify A, H, and K. Those will give us the transformations. Number 4, list the transformations, okay, from the parent functions. So those are these right here. Number 5, make a new table of values using the transformations. H is going to be added or subtracted to x. The A gets multiplied to y, and the K gets added or subtracted to y as well. Graph your points, and then give us the characteristics. So we have example 2 to 3. Graph each and find all characteristics. So 2 is 1 over x minus 2 plus 5. Remember, this is the y equals 1 over x, okay? And then we have minus h and then plus k. So because this is a minus 2, your h is going to be 2. Your a, this is your leading coefficient, so that's going to be 1. And then your k is going to be the number that's added or subtracted behind the fraction. So in this case is 5. Let's make your parent equation, which is y equals 1 over x. And we want to pick values for this, okay? Remember, the parent function has x can never ever be 0 and y can never ever be 0. So let's pick some x value. We're going to pick negative 2, negative 1, negative 1 over 2. We can't pick 0 because that's going to give us your asymptote. Then we're going to pick 1/2, 1, and 2. And let's check it in. All right, guys, here we go. All right, let's plug it into this parent, remember? So 1 divided by negative 2 is negative 1/2. 1 divided by negative 1 is negative 1. 1 divided by negative 1/2, students, we now know is negative 1/2. 1 divided by half is 2, 1 divided by 1 is 1, 1 divided by 2 is now 1 over 2. So this is the parent function. Now we want to transform using your a, h, and k. So let's look at your a, h, and k. So we have an a value of 1, so we don't need to multiply by y by 1 because it doesn't change anything. Your h and your k gets written in here. So h is going to be added to x, so x plus 2. Your k is going to be added to 5, or y, because it's positive. So we are going to take all of this right here, guys, and then transform with this. And then we are going to take all your x's, and then, now all the y's, and transform it to this, okay? Take a few minutes to do so. Okay, so hopefully you guys got the same values as I do here. And then let's plot them, okay? Okay, so your transformations are going to be, you have the h and k only. So the h, because it's positive 2, we are going to go right. Okay, we're going to go right 2 units. Then the k value is 5, so that's going to be up 5 units. Those students will also give you the vertical asymptotes and the horizontal asymptote. So let's graph. If you go right, remember the parent function, let's go up really quickly. The parent function has a vertical asymptote here at x equals to 0. So if you go right 2 units, that's going to move the vertical asymptote to the right 2 units. So that is also going to be, your h is also going to be your vertical asymptote. So this is going to say x equals to 2. So let's go and fill out your vertical asymptote as well. X equals to 2. Now your 5, guys, is going to be y equals to 5 for the horizontal asymptote. Because let's look up really quickly. Okay, so you had a horizontal asymptote at y equals to 0. Let's get pink right here. Y equals to 0. Because we are moving up 5 units, guys. So now your horizontal asymptote is now going to be y at 1, 2, 3, 4, 5. So we have 2 asymptotes. We were always going to have 2 asymptotes. This is your y equals to 5. So h and k will give you 2 asymptotes immediately. Okay, the h is the x equals 2. The k is the y equals 5. So let's plot our transformation table, the x and the y's. 0, 4.5. So 0, 4.5 is right here. 1 up 4, and 1.5 go up 3, so that's going to be this. Don't touch your asymptote. So go like that, don't touch it. Okay, just like that. Okay, so we are going to we get very, very close to the asymptote, but don't ever touch the asymptote. Now on the bottom here we have 2.5 go up 7, 5, 6, 7. So 2.5, 2 points go up 7, 3 go up 6, and then 4 go 5.5. So again, you can go off the grid, just don't touch your asymptote, get close to it, and that's what it should look like. Okay, it looks like we do have an x-intercept and a y-intercept, so we can't really eyeball that. We would need to come back and solve for it. Your domain is going to be all real numbers, okay, except 2. So we're going to write negative infinity. The reason we say except 2, guys, is because this x right here, that's your asymptote, so we cannot use that. So that's going to be all real numbers except 2, or negative infinity to 2, union 2 to infinity. Your range is going to be all real numbers except your asymptote, which is 5. So the way that we write that is negative infinity all the way to 5, not including 5. So that's why it's parentheses, it's non-inclusive. It is going to be a decreasing interval because we are going down and down and down closer to 5, and this one as well, right? It's going downward. Doesn't matter what we do. So decreasing interval is from negative infinity to 2, and then that's going to be union 2 to infinity. So it's going to be exactly the same as your domain. Everything is decreasing, so nothing's left for increasing. This is going to be a 1-to-1. So the only 2 things we have to work out for this question by hand are going to be your x-intercept and y-intercept. So let's do your x-intercept right over here. So x-intercept, let's get this color. X-int is when y equals to 0. 0 equals 1 over x minus 2 plus 5. Step number 1, students, minus a 5 over. So negative 5 equals 1 over x minus 2. And students, your lowest common denominator is going to be x minus 2. So multiply each side by x minus 2. Multiply this side by x minus 2. Remember, over 1 or not over 1, that would be the same. So this will allow us to say, okay, well, this and this is going to be reduced, get down to 1. And then over here we have negative 5 times x minus 2. Distribute this out. So negative 5x plus 10 equals 1. So we are now going to minus 10 to both sides. Negative 5x equals negative 9. X equals negative 9 over negative 5, which is positive 9 over 5. And we have to write it as an order pair. You can write it 1 4/5. That's okay too. So it's going to go 9 over 5, comma 0. Or you can write 1 4/5. 1 4 over 5, comma 0. Okay. Y-intercept, guys, is a little bit easier. So we'll do y-intercept right here on the top. Y-int is when x equals to 0. So we are going to take y equals 1 over 0 minus 2 plus 5. Well, 0 minus 2, guys, is going to be a negative 2. So this allows us to say y equals 1 over negative 2 plus 5. Well, a negative half plus 5 is a positive 4 1/2. Okay, now that will also tell you, hey, we already have that right there. So technically we don't need to do anything, but that confirms that's how we get it. So 0, comma 4 1/2. And let's pinch it all in so you can see the whole thing.